Hello, my wonderful viewers. Welcome once again to Frequency Online Maths. Let's quickly solve this number 5 example. We have y prime prime plus 4y is equals to 0. Then y parenthesis 4 is equals to 4. Y parenthesis 0 is equals to 4. Y parenthesis 0 is equals to what? 6. So we write our solution. If you notice well, this is not the usual question we have been solving, but I told you earlier that C1 and C2 have their what functions. So that C1 and C2 are used for finding initial value problem and boundary value problem. So this type of question is initial value problem. Why is it initial value problem? Because y is at what? A point. And y prime is at what? A point. You understand? So y have a point which is 4 and y prime has a what? Point which is 6. For example, if we have y of 0 is equals to 3 and y prime, okay, y of 0 again is equals to 2. So this one is boundary value problem because y has what is at what 2 points, which is the original function of what y is at what 3 and y is at what 2. You understand? So this is very boundary value what problem. But under initial value problem we have y at what point, normal y at point 4, at a point 4 and y prime at a point what 6. But this one y is at what 2 points. You understand? 3 and what 2. So that is how to distinguish whether it is initial or what um boundary valued what problem. So we write the question y prime prime plus 4y is equals to 0. So using our this thing characteristics equation, we're going to have a r squared plus bx plus c is equals to 0. So our a here will now be 1 r squared, our b will now be 0, 0x. Sorry, this thing is r, br. So 0r plus our c will now be 4 is equals to 0. So we have 1 r squared plus 4 is equals to 0. So r squared is equals to minus 4, right? So r is equals to square root of minus 4 when you square both sides. So we are going to have r is equals to 2i using what? Square root of what? Minus 1. So our r is what? 2i. So we are going to have, remember, r1 is equals to 2i and r2 is equals to 2i. Why? R1 is 2i, R2 is what? 2i. Therefore, the roots are complex. So the roots are what? Complex. So we are going to have R1 is equals to alpha plus beta I. Then R2 will now be alpha plus alpha. This time around it will be minus beta I. Minus beta what? I. So we are now going to have our alpha will now be R1 is alpha will now be 0 plus 2i. Then R2 will now be 0 minus 2i. So alpha is equals to 0, beta is equals to 2. Just like that. So we're going to have y is equals to exponential alpha x, then c1 cos beta x plus plus c2 sine beta x. So our y will now be exponential alpha is what? 0 x, then times c1 cos our b is what? 2x, our b is what? 2 plus c2 sine 2x. So automatically this thing is equals to 1 times this, so no need. So we have c1 cos 2x plus c2 sine 2x. Now, because we are looking for the initial value problem, remember our y 0 is equals to 4. So anywhere we see y, we put what? 4. So we are going to have 4. I hope you can see it. Okay, if I finish writing here, I'll move over to the other side. So our y is equals, remember when y is 4, x is what? 0. And we are going to have 4c1 cos 2 times 0, so which is 0. Then plus c2 sine 2 times 0, which is 0. So we are going to have it like this. We are going to have 4 is equals to c1, because 0 is what? 1 times c1 is c1, plus sine 0 is what? 0 times this will give us 0. So c1 is equals to 4. Now, since c1 is equals to what? 4, we are going to put it where is that our this thing equation? Okay, let's not put it in our equation. Let's first of all find our y prime of what? 0. So bringing y prime of 0 is equals to 6. I hope you can see it from there. Okay, let me shift it a little. So bringing y 0 is equals to what? 6. So how can we find our what? Y prime to substitute this value as we did in this first equation? So what we are going to do is we bring this equation here. Y is equals to c1 cos 2x plus c2 sine 2x. Can you see it? Okay, it's like I'll clean the other side. Okay, you can see it now. So our y, this thing now, we have brought it. Now find the derivative. So we find the derivative of this so that we can obtain this thing now, so that we can substitute. So the y prime will now be, I don't think this thing will contain here. Y prime will now be derivative of this c1, derivative of cos 2x will now be minus sine 2x times 2 using function of a function. So then plus, we bring down out this c2. Now the derivative of this one will now be cos 2x times 2. We close it. So y prime will now be, this times this will now give us minus 2c1 sine 2x plus 2c2 cos 2x. So we are going to have, okay, let me clean this side. So we are going to have y prime is equals to 2c1 sine 2x plus 2c2 cos 2x. So y prime parenthesis 0 is equals to what? 6. So we are going to replace it here. So remember, x will be what? 0. So we have, anywhere we see y prime, we put what? 6. 6 is equals to 2c1. Our x is 0. 2 times 0 is what? 0. Sine 0 is what? 0. So we have this. Then plus 2c2, because 0 is what? 1. So which is what? This. So okay, automatically this one is out. This one is out. Because 0 times this will give us what? 0. So we have 2c2, 2ct only. So we can divide both side by 2. Divide both side by 2. So our C2 is equals to 3. 6 divided by 2 is what? 3. So C2 is equals to 3. Now, our C1 is equals to 4. C2 is equals to 3. These are our initial value problems. So we are going to bring back our equation. Bringing back our equation is going to be y is equals to C1 is what? 4. So we have y is equals to 4 cos 2x plus our C2 is what? Sorry, C1 4, C2 is 3. So plus 3 sine plus 3 sine 2x. So this is our answer. Thank you for watching and may God bless you. Don't forget to subscribe. In our next video, we are going to solve for boundary value problem. Bye bye.